All right, welcome in everybody. What do we got here today? We got 12 people so far. So a special treat before we get going. Bambi wanted to come in and say hi before we go. So here's Bambi, my old gal, 14 years old. Okay, you go out now. So, anyways, hopefully everybody had a good weekend. I don't know if you guys are Casa de Papel fans. That's what I spent my whole Friday evening until about 1 in the morning binge watching. So if any of you else watched that show, hopefully you enjoyed it as much as I did. So today we are doing 3.1 and 3.2. Again, like the last time, might have even been able to get all the information, but we'll kind of break it into the two sections. From 3.1, we are talking about quadratic equations in standard form. And so, hello. So standard form is this form here. So a x minus h squared plus k. And it's when we take a regular quadratic expression and we complete the square in order to put it into this form. And then once we have it in this form, the vertex is at hk. So it's a parabola. So remember that any quadratic is x squared with something. So that's going to be a quadratic. It's a parabola. If a is positive, the parabola is pointing upward. If a is negative, it's pointing downwards. And then the max or min occurs at the vertex. Now, the important thing. So I know some of the homework questions said, what's the maximum value or what's the minimum value? So the key here is that the max or min occurs at the point when x is equal to negative b over 2a. And so first you have to figure out what is that value of x, then you plug it into the quadratic expression or the function in order to get what the actual value would be. So just be careful with that. That's where a lot of the trouble will come in most of the time. That's really about it. There's not a lot of exams from 3.1. 3.2, I'll have to see if I can put that on the exam. Usually you have to graph a polynomial. But since you're going to be doing everything with the online quiz, I don't know how much I'll be able to. I may have to just have a choice of like maybe 6 graphs, and you have to pick one of those 6 is what the graph would be. So I'll have to figure that out. Certainly before exam 3, I'll let you know any of that. So any questions on 3.1, the concepts here, standard form, or where does the max or min occur? All right, so let me erase this. So I had only a couple questions that were posted on the discussion thread. No, okay. So we will do those. And again, remember, just if you guys do have questions to post it on there, that way I can kind of see what numbers you guys have. Otherwise, even if I log on to WebAssign, I can see what the question is, but not the numbers. And then it becomes kind of an issue of figuring out, okay, what numbers do you guys have? So the first one is from 3.1. It's number 3. And you are given the function f of x is equal to x squared plus 4 x. So x squared plus 4x. Also, so before we get into this, I put the feedback discussion thread as well and had across the classes quite a bit of feedback. So I do appreciate you guys letting me know your thoughts so far. And it seems as if everybody's okay with this format for now. So we'll stick with this. Certainly one good thing is that you guys can go back and watch it. I was looking at some of the previous like video streams, and it looks like there's 100 views already. And so obviously there's not 100 of you guys. So either people are going back, watching it a couple times. I think maybe even some other classes might be kind of piggybacking on it, and that's fine. But specifically for you guys, if you do have questions, make sure you put them on there so I can make sure that what we're doing in the video is what you guys need help on. So the first thing we have to do is express this in standard form. So what we're going to do is complete the square, and the process is still the same. So we're going to take our b, which in this case is positive 4, take half of that, which is positive 2, and then square that value, which would be plus 4, so positive 4. Now, the way that we were doing completing the square before, so when we had either the quadratic equation, we were trying to solve it, or if we had the circle and the radius problem, we always had an equal sign. So if I added 4 to the left, I could just add 4 to the right. But now I don't have that. All I have is this, x squared plus 4x. So if I'm going to add in the 4x here so that I can complete the square on this part, the only way that I can keep this thing equaled out is if I added 4 here, is to subtract a 4 right next to it. Plus 4 minus 4, that's 0, so I still end up with x squared plus 4x. Because I can't change what I started with, I can only change the way that it looks. And so that's what I'm doing here. I'm adding in a 4, which means I also need to subtract a 4 right next to it in order to keep everything the same. So does that make sense before I move on to the rest of this problem, why we're adding 4 and then subtracting 4 right next to it? So any questions? Again, just remember, if you have a question, type an exclamation point or a couple of them. That way I know to hold on before I move on. Okay, yes, that makes sense, I'm assuming. That's what the yes means. Good morning, Billie Jean. 6 a.m. again there, I'm assuming. All right, so it doesn't look like anybody has questions, so that's good. So now break this guy down just like we did with the circle problem or did with the quadratic equations. This is going to be x and whatever half of b was. So plus 2 minus 4. So now it's in standard form. We have this invisible 1 in front for our a. So now let me look at the problem here. Which one was this? Number 3. All right, so we wanted the, standard form, then the vertex and the intercepts, okay? So standard form, there we go, and you don't need the 1. So just x plus 2, squared, x plus 2 squared minus 4. So the vertex, where? Well, it's inside the parentheses. It's the opposite of what I see. So negative 2, and then outside here, my k is negative 4. So that's my vertex. The x-intercepts. So x-intercept is what? It's when, so I'll give you a little tip here. So for x-intercept and y-intercept, sometimes it's easier just to go back to the original. So for x-intercept, we do what? We set the function equal to 0. So if I have x squared plus 4x equals 0, I can factor an x on the left side. So I get x plus 4. And now use my 0 property rule. We have what? X is 0 and x is negative 4. So those would be my x-intercepts. Again, you could set this one, so there's our function. You could set this equal to 0, so then move the 4 over, then take the square root and plus or minus, and then subtract 2 from the other side. It's still going to give you the same thing. X is 0, x is negative 4. So a lot of times it's easier just to work with the original. Same thing with our y-intercept. Because the y-intercept, what do? We set the x variable equal to 0. So if I go back to the original, I plug in 0 for x. This is 0, that's 0. So the the y-intercept is just the point 0, 0. And was that it on that question? Let me double check. And then sketch it. So is the sketching function working okay for you guys? I know a little bit earlier in the semester when we were like drawing parabolas and things like that, people were having some issue with the graphing feature. Is that working okay now, or is it still funky where you're trying to graph a parabola and it's not coming out as a parabola? One thing I will say too about this graphing, sometimes if you graph something and then you submit it and it's not correct, even if you clear it, for some reason, sometimes the system thinks like that graph is still there, even though you cleared a function. So sometimes you have to log out of WebAssign and log back in and then resketch it. Hopefully you don't have to do that too often, but sometimes that resolves the issue. All right, so I guess we're good on this one. No issue with it. Okay, good. It's hard to doable, glitchy. Okay. All right. Number 5 is the next problem it was asked about. And you have 1/2 x squared plus 2x minus 10. And we want to find the maximum or minimum value. So was it f of x? Yeah, h of x, okay. I think there is a clear all button. Yes, so there is a clear all, and it will do that. It'll clear out the graph. But for some reason, and I don't know why, but sometimes it still like keeps in the memory the graph. So even though it clears it off on your screen, the memory of WebAssign thinks that the graph is still there. So let's say, for example, it was supposed to be a parabola and you first graphed the line. Well, that's wrong. So you clear all and then you put in the parabola. WebAssign thinks you're putting in this picture because even though you clear all, it still has this just a line in there as like a ghost image. And so sometimes, like I said, you have to, I don't know why it is. I just know from past semesters, if you log off a WebAssign, log back in, then regraph it, then it works. Like it completely clears it out. So if you have that issue, just try that. Try logging off, logging back on. Okay, good. Well, that's good that maybe they resolved it. So maybe they had enough complaints that they fixed it. All right, so first off, for this problem, h of x is equal to this guy. It wants to know the maximum or minimum value. Now, that value occurs at the point negative b over 2a. When x is equal to negative b over 2a, that's the maximum value of this. So first we have to figure out what is x equal to, then plug that into this function. So we have what? Negative b, which is 2, over 2 times a, which is a half. So this is what? Negative 2 over 2 times a half is 1. So negative 2. So negative 2 is not the maximum or minimum value. When x is equal to, that's where the maximum or minimum value occurs. So we have to figure out what is h of negative 2. Take this value, plug it into the function. So we get 1/2 times negative 2 squared plus 2 times negative 2 minus 10. So does that make sense to everybody? The slight difference there. It's not what's this value, negative 2. That's not the maximum or minimum. That's where it occurs. So that's the value we have to plug into the function. All right, doesn't look like any issues, so let's move on. Simplify this. So we have 1/2 -2 squared is positive 4. 2 times -2 is -4 minus 10. 1/2 times 4 is 2. So we have 2 minus 4 is -2 minus 10 is -12. So the maximum or minimum value is equal to -12. And then how do I know if this is a maximum or minimum value? I'll pose that question to you guys. So I know that -12 is the maximum or minimum value, but which one is it? Is it the max or is it the minimum? It's not. So it has nothing to do with this negative sign. It's max, it's max, it's max. Negative is minimum. So nope. So again, this number could be plus 12. This number could be minus 12. That doesn't tell me anything about whether it's a maximum or minimum. What am I look? So let me ask you this. We know that this guy's a parabola because it's an x squared. Yes, Alex, perfect. So what am I looking for? I'm looking at the a value, the number in front of the x squared term. If this is positive, which way is the parabola pointing, up or down? Exactly. So this is where it's a little bit counterintuitive. So if a is positive, this guy is some parabola. Actually, I won't even draw. So I know that this thing is a parabola that's pointing upward because a is positive. So this value that I figured out is what? It's at the bottom of the parabola. So if it's at the bottom of the parabola, it means what? It's the minimum value. So if a is positive, it's a parabola pointing up, this number is the minimum. If a is negative, so if there was a minus in front here, the parabola is pointing upside down, which means the value I just calculated would be the maximum value. So it's a little bit tricky because it's the opposite. Oh, you think a is positive, it must be maximum. It's the opposite. So my parabola is pointing up. So the point that I figured out is it's at the bottom of the parabola, so therefore it's the minimum value. Does that make sense there? Any questions on that? Do you guys need further explanation? Got it, makes sense. So maybe that could be a concept question on the next exam. If a quadratic function, if a is positive, does it have a maximum or a minimum point? Well, it would have a minimum point. And that's why if a is positive, it's pointing up. Therefore, it has a minimum. It never has a maximum, though, right? Because this thing goes on to infinity. So it doesn't have a maximum. I guess the maximum is infinity. That value that we can actually calculate. All right, makes sense. So that was the questions on 3-1. I think there's only maybe 5 problems or something, so there wasn't a lot. Like I said, there's not really going to be much from this section on exam 3 or the final. So I'm not going to give you guys a quadratic function and say put it in standard form. So you're not going to have to do that. If anything, and again, I'll give you guys a list of the concept questions. If anything from this section, it might be, if a is positive, do I have a maximum or minimum point? All right, so 3-2. So let's look at the notes from 3-2 first. And 3-2 is graphing polynomial functions. So let me see here. Okay. So let me give you these steps for graphing this. First of all, you want to find the zeros or the roots. Step number 2, so I'll call it 0 or roots. Step number 2, find the y-intercept. And how do we do that? We do that by setting x equal to 0. 3, we want to determine the end behavior. And actually, let me add something here to 1. So we're finding the zeros, and not just the zeros, but the multiplicity of those zeros. And so multiplicity, and so once we have that, then we can just sketch it, because we'll know where it starts and ends. We're going to know where it hits the x-axis. We're going to know where it goes through the y-axis. We know, starting and ending, so we can sketch it. For multiplicity, so this is how many times a root repeats itself. If it has multiplicity of 1, then it simply crosses the x-axis. If the multiplicity is even, so 2, 4, 6, 8, 10, etc., then the graph is going to bounce off the root. And if it's odd, greater than 3, well, greater than or equal to 3, so 3, 5, 7, 9, etc., then it does what I think in the videos I call it snakes through. So instead of crossing through, like if multiplicity is 1, it kind of levels off and then takes off again. So if we know this information here, and if we understand how multiplicity works, we can basically graph polynomial functions. So any questions on anything that was in the videos didn't make sense? I guess realistically, you could probably put that in the discussion thread. I didn't think about that here till now. But the homework discussion thread that's on Canvas, if you do have questions on the video and you want to type it in ahead of time, maybe I can even respond before our class period here. So, all right, so let's look at an example, question someone had. And this is question number 6. So you have a polynomial function, x minus 1 squared, and x plus 6 to the 3rd. And let me just pull this up again to make sure what the question is. All right, so you just have to sketch it. So let's go through those steps. First of all, we want to find the roots. So to do that, if this polynomial wasn't factored already, we would have to factor it down. But it is factored. So we're just taking what's inside the parentheses, the x minus 1, set that equal to 0. Take the x plus 6, set that equal to 0. So that means x equals 1 is one of the roots. X equals negative 6 is the other root. We have 2 roots here. Now let's figure out the multiplicity. So for x equals 1, that's this guy here, multiplicity is just the exponent that we're looking at. So multiplicity for this one, so m is equal to 2. So that means what? That means that the graph is going to bounce off of this point, off of x equals 1. And for x plus 6, that's multiplicity of 3, which means it's going to kind of snake through the graph. Any questions to that point before I move on? All right, so then I want the y-intercept. So y-intercept, we just plug in 0 for x. So we have 0 minus 1 squared times 0 plus 6 to the third. So this is negative 1 squared, which is positive 1. This is 6 to the third. What's that? 36, 216. It's a lot harder when I don't have you guys in class to tell me the numbers. So let me double check. Not that I. So we had 6 to the third. 216. Good. All right. So my y-intercept is at 216. So way up high. And then lastly, I need to figure out the end behavior. So the end behavior is based on the highest degree term that I have in this polynomial. I could multiply this whole thing out and multiply this whole thing out and then multiply both of them together, but I don't really have to do that, right? Because I have what? From this one, I'm going to end up with x squared and something. And when I multiply this one out 3 times, it's x to the third times or plus and minus something. So then when I multiply these two together, the biggest term I'm going to have is the x squared times the x to the third. So essentially, all you have to do is multiply the exponents. If I had a bunch more factors of this, I would multiply those as well. So I get what? 3x's and 2x's. So 3 times 2 is 6. So my end behavior is the equivalent. So it's based on x to the 6th. I have 3 here. I have 2 here. 3 times 2, 6. So does that make sense to everybody? Not 6, 5. I'm adding because I have same base, add the exponents. Sorry about that. Based on x to the 5th. Like I said, I'm adding the exponents, 3 plus 2, not multiply them. So sorry about it. Based on x to the 5th power. I have 2 here and 3 here, total of 5. Sorry. So then we have to draw this guy or sketch it. So let me try to draw a graph in over here. Let me erase some stuff here so I can get this in a little bit better. All right, I'll try to squeeze the graph in down here. Hopefully we can do this. So we have a point. Let me at least just erase this. So end behavior is like x to the 5th. So on my graph, my roots are x is equal to 1, x equals negative 6. So at x equals negative 6, I have 1 point here. I have another point at x equals 1. X to the 5th. So there's no negative in front here. So if you guys remember from the video, I had mentioned that any of the odd powers, so x to the 3rd, x to the 5th, x to the 7th, etc., they all have the same starting and ending position. They're starting down here in negative infinity on the left and ending up here, positive infinity on the right. So my graph is going to come up to x to the negative 6. And it does what? It snakes through. So it's actually going to go through here. Let me move this negative 6 over to here. It's going to kind of flatten off a little bit and then start heading upward again. So my end behavior, it starts in the lower left. It goes to the y-intercept, so way up here at 216. Then it comes screaming down here to x equals 1. And what happens at x equals 1? It bounces off the x-axis. So it comes down and then bounces off and then does what? Heads to the upper right. So these problems almost let you check it as you do it, because I know I have to start down here and I have to end up here, and these couple of different things happen as I'm graphing. So if all of a sudden, if I would have said that, oh, it goes through 1 and has to end up down here, I know that I have something wrong. So I know I have to start down here, snake through this point, go through my Y-intercept, bounce off of this guy, and end up there. If all that doesn't connect, then I know that I've drawn the graph incorrectly. So does that make sense to everybody? Any questions on that one? All right, yes, makes sense. Okay, so let me erase this. Let me give you guys another example just to make sure you guys do understand this, and let's call this the attendance problem for today. So if you want to put this in your take it out the notebook, take it out the door notebook for now, that's fine. I'll give this to you guys, give you a few minutes to try it, and then I'll out here, or we'll go through it. So let's say P of X is equal to X minus 2 times X plus 1 to the third power. So go ahead and sketch that guy. You guys met Bambi. While you're working on that, I'll see if I can find Ginger. So you have P of X is equal to X minus 2 times X plus 1 to the third. So just process it through like we did the last one. What's the roots? What's the multiplicity? What's the Y-intercept? What's my end behavior? And then put those guys on the graph, see if you can figure it. Ginger, you want to be on video, Ginger? He was already on. Another day or later. Ginger's too sleepy, so maybe later. Maybe she'll come around later. So again, try this guy. If you have questions along the way or you want to confirm your work, just go ahead and type it in. And again, like last time, when you guys are done, just go ahead and type done, so that you're not waiting on me, waiting on you. All right, good. Looks like you guys are finishing up here. All right, looks like we got about half you guys, a little over half done here. So let's go through this. First thing we want is the roots. So I'm setting x minus 2 equal to 0 and x plus 1 equal to 0. So this means x equals 2, x equals negative 1. Now for the multiplicity. So for the first one, multiplicity is just 1 to the first power. So this means it's just going to cross through the graph. It's not going to bounce. It's not going to snake its way through. Just going to go straight through. For this one, multiplicity is 3. So this one, it is going to snake through. It's going to level off and then take off again. Oh, might be something wrong with my internet. I might have lagged out. So everybody else okay? Everybody else hooked up here? Hopefully. All right, then our y-intercept. So I do what? I set x equal to 0. So I have 0 minus 2, and then 0 plus 1 to the third power. So this is what? Negative 2, 1 to the third, which is just 1. So my y-intercept is at negative 2. And then end behavior. So I have what? Add the exponents. 3 plus 1 is 4. So this is basically like my x to the fourth graph, which is a parabola. There's no negative in front, so it's a parabola pointing upward. So that means I'm starting up here in the upper left. The graph is going to do a bunch of stuff, and then it's going to end up in the upper right. My roots. So make sure you mark the roots and not the multiplicity. So my roots are at 2 and at negative 1. The y-intercept is at negative 2. So those are the points that it's hitting on the graph. And so what happens here? It starts here in the upper left. It's going to cross through. Oh, sorry, no, it snakes through at negative 1. So it's going to come down here, level off a little bit, and then start heading back down again. It's going to go through the y-intercept, so here. And then at x equals 2, it crosses straight through. So from here, it just comes straight through and ends up at the top. So this guy kind of levels off and ends up there. So it has sort of that parabola look. We have this little funky thing going on at the bottom here, but otherwise that more or less should be what your graph looks like. Does anybody not have that? Have any questions how we got something or why the graph is doing some certain move at a certain point or something? Any questions you guys have on that one? And just make sure you put this in your ticket out the door notebook as the attendance problem for today. All right, no questions, I guess, or everyone's logged out. Still with us, Marco? Or did you get kicked out of the system there? All right, so then the last thing I want to talk about, and then I'll give you guys your ticket out the door, was one of the assessment problems. So nobody asked about it. Okay, no question. Good. Nobody asked about it from your guys' class, but somebody asked about it from the 230 class, so I just want to address it anyways. And one of the assessment problems, number 6, it was f of x is equal to 6 minus 3x to the third power. Oh, okay, question. Oh, hold on. Use clear how you got the end behavior. Okay, so what do we have there? We had x minus 2 and then x plus 1 to the third. So if I expanded this whole thing out, if I multiplied this over 3 times, I'd have x to the third plus or minus a bunch of stuff. And this guy here is x minus 2. So then if I distributed this, x times all of these guys, 2 times all of these guys, combine my like terms, I'm essentially, the biggest one I'm going to have is x to the first times x to the third. If we remember our exponent rules, when we have the same base, we just add the exponents. So this is going to end up x to the fourth plus or minus a bunch of stuff. So really all I have to do is just whatever my exponents are, 3 and 1, is add them. So that tells me the end behavior is similar to if I just graphed x to the fourth. Yeah, we yeah, you can think of it that way too. We add multiplicities because all the multiplicities has to do with our exponent. So yeah, if you want to think of it that way, that's probably a good way to think about it. Add the multiplicities. If you add the multiplicities, that's your highest degree term of that polynomial. And therefore, that tells you what the end behavior is going to act like. Yeah, so good one. Yep, you're welcome. Okay, so back to this guy then. This was one of the assessment questions. Number 6, and you had to find out what is the inverse of this function. So what are our steps? We set this thing equal to y. Then we have to get x by itself. So we do what first? We subtract 6 from both sides. We have y minus 6 is negative 3x to the third. Divide everything. Now we can, let's just divide by -1 to start with. We'll do this in a couple steps here. So we get what? 6 minus y, because minus y here, negative makes us positive. Cancels out, so you get 3x to the third. Divide both sides by 3. So we end up with x to the third is equal to 6 minus y over 3. Now, I have x to the third equals this, so how do I get x by itself? What do I have to do here? How do I get x by itself? Not square root, close. So if this was x squared, then yes, then I would take the square root. Exactly, Marco. Yep, everybody else, yep, timing it perfect. The cube root. So in this case, if this was x squared, I would take the square root. Because it's x to the third, I need to take the cube root of both sides. So I get x is equal to the cube root of 6 minus y over 3. And the last step is switch our x's and y's. So f inverse of x is the cube root of 6 minus x over 3. So again, if this is x to the third, I need to take the cube root. If this would have been cube root of x, then I would have had to take everything to the third power, to the cube power, cube everything. So does that make sense? It's similar to what we looked at the other day with like our square roots and our squares. The only difference is now it's cube roots or cubes. So just be careful. Whatever power you're trying to get rid of, that's the root that you need to take. Does that make sense to everybody? All right, good, makes sense. Okay. All right, and I will give you guys your ticket out the door for today. If you do have any other questions, post. I would say send me an email. For some reason, when you guys, yeah, if you post it on the discussion thread, it does email me for that, so that's fine. Yeah, if you have any other questions on this section, if you want to post it in the discussion thread, excuse me, that's fine. I can answer it through there. So, because then you can post pictures and whatnot. So your ticket out the door for today. First one. So sketch P of X is equal to X plus 1 times X minus 3 squared times X minus 1 to the 5th. And number 2, if R of X is equal to X plus 1 over X squared minus 4, then find the following. What's the X-intercept? What's the Y-intercept? What's the vertical asymptote? And what's the horizontal asymptote? So go ahead and try those. Oh, thank you guys. Yep. I swear it's not Corona, just dust probably. So yeah, so go ahead and try those. Again, I'll give you guys a few minutes to work on this. If you have questions, otherwise I can post the answers up. And so maybe once you guys think you're done, if you want to type done, then I will start posting the answers. That way, if you don't have something, I can kind of run through how we get those answers. And that way, if you have them, then you're free to go for the day, and we'll talk to you on Wednesday. I'll post another thread for, I think Wednesday we only do 3-3, only one section then maybe. But I'll post that discussion thread up as well. So if you guys are working on that, you can post any questions you have there. So ultimately, I just need the sketch of the graph, but if you don't find the roots, multiplicity, line behavior, yeah, so as Marco says, you kind of need all of that. I suppose you could probably try to plot points if you want, but it's going to get super messy. So let's say this was the final exam and this question was on there and you couldn't remember how to do all the roots and multiplicity and those kind of things, you could just pick points and plug them in and see what the graph looks like. But in this case, then you'll have to find all that different information, and that kind of leads you to what the graph is going to look like. Yeah, it definitely does. And without the steps, it's kind of hard to know where the information is. Okay, Billie Jean, give me 1 second. We'll give people a little bit more time, and then I'll put the answers up for you. Okay, since a few of you are starting to finish it up, I'll put up the answer, so at least if you have it, you can take off. So let's talk about the roots. So the roots are going to be -1, 3, and +1. The multiplicities are 1, 2, and 5. So therefore, it's going to cross here. It's going to bounce here. It's going to snake through here. And the y-intercept, when we plug in zeros, we get 1 times -1 times 9. So that gives us -9 is where our y-intercept is. Then end behavior. And I forget who to give credit to. I'll have to go back and look. But yeah, if we just add multiplicity, 7 plus 1 is 8. So this is like x to the 8th, which is a parabola. So I'm going to start in the upper left, do a bunch of stuff, end in the upper right. So my y-intercept is at -9, so way down here. One of my roots is -1. That's just going to cross right through. At +1, it's coming back up. It's going to kind of snake through here. And then at 3, it bounces. So I know I come down through here, through my y-axis. So your graph should look something like that. Again, it says sketch. You get, Alejandro, you're the one I think I owe credit to for this multiplicity. So your graph should look like that. Yep. Move on. Uh-oh. Okay, it just flashed. My internet connection was unstable there for a second, so hopefully we're back up and running. All right, so for this one, x, we do what? Set the numerator equal to 0. So x is -1. So the point would be -1, 0. For my y-intercept, that's what? Set x equal to 0. So these two are gone, so it should be -4. So 0, -4 should be my y-intercept. Vertical asymptote, what do we do there? We set the denominator equal to 0. So this becomes x plus 2, x minus 2. So I have two vertical asymptotes. I have x equals -2 and x equals +2. So two vertical asymptotes. And then last but not least, the horizontal. What do? I'm looking at the exponents. The bigger exponent, they're not the same, so it's not going to be the ratio here. The bigger exponent is in the denominator, so that means what? That always means the horizontal asymptote is y equals 0. The x-axis would be my horizontal asymptote. So that should be your guys' answers for both of those. If you got them, great. If you didn't, you want to stick around, ask a question. I will hang out here online for a little bit. Otherwise, hopefully everybody was able to stick around with the internet connection. I don't know what happened there, but hopefully you guys are still on board. If you don't have any questions, then we will talk to you guys on Wednesday. As I said, if you do have questions, go ahead and type it in, and I'll try to answer it as everybody else leaves. Otherwise, you guys have a good night. Stay safe. We'll see you Wednesday. All right. Thanks, Alex. You too. Thanks, Taylor. All right, Marco. Have a good night. All right. Thanks. Bye. Bye, Jenna. Bye, Cassidy. You guys be well as all. Yep. Thanks. You too, April. All right. Looks like everybody's dropping off. No questions. So I'll shut down the stream. You guys have a good one. We'll see you Wednesday.